Okay, let's dive into this. Welcome to The Explainer. Today we're unpacking something literally completely unexpected. We're looking at a fourth grade science simulation called the Cove. It was created by Chalk and Ledger Group. But honestly, here is the secret. It's not a science project at all. It is actually this brilliant psychological heist, perfectly disguised as a marine biology mission. So let's get into it.
Picture this. You're a marine biologist arriving at the Coral Cove research station. You're tight on time, tight on money, and you're staring down your first two dive options for the day. Option A is Sunrise Reef. We're talking crystal clear water, colorful coral, tropical fish darting everywhere. It's literally a postcard. Then there's Option B, Seagrass Flats. And well, honestly, it looks like a muddy underwater lawn. It's brownish green, super quiet, and there's almost zero visible movement.
So, here's the million-dollar question for you. If you had limited time and limited money, which of those reef zones would you choose to study? Go ahead and lock in a choice right now in your head. If you're like pretty much every single fourth grader out there, and let's be real, most adults too, your brain intuitively screams at you to pick Sunrise Reef. I mean, it's gorgeous, so it absolutely has to be the best spot, right? Well, just hold on to that thought for a second.
Before we go any further, you kind of need to understand the intense pressure cooker these student scientists are operating in. The rules of the simulation are strict. You get exactly 10 dive hours a day. That's it. You only get 5 lab tests. You have a ruthlessly tight budget of just $500 for the entire week and a 5-day mission timeline to produce a final report. Every single choice eats up precious resources.
To keep everything from falling apart, the kids are broken up into teams with very specific jobs. You've got a dive planner, a lab manager, and a research reporter. But now what's really interesting here is the data analyst role. Their absolute required daily job is to read the environmental data out loud before the team is allowed to vote on anything. They're essentially acting as a deliberate cognitive speed bump. The creators put this in there specifically to stop the loudest voice in the room from making snap decisions based purely on how things look.
The whole thing plays out over an intense 5-day arc. Day 1 is surveying. Day 2, the data returns. Day 3 brings a storm warning. Day 4 is the aftermath. And Day 5 is the final research report. It moves really fast. And it all kicks off on Day 1, which the designers actually secretly call the pretty versus boring trap, because that's when students confidently lock in their very first zone choices based on those initial surface-level descriptions. Then, Day 2 arrives. The data analysts read the lab results out loud, and boom, the trap springs. Listen to this actual quote from the source material. Sunrise Reef found common species. Seagrass Flats found juvenile sea turtles and seahorse colonies. Critical nursery habitat identified. Yep, that ugly, muddy underwater lawn completely outperformed the pristine, postcard-perfect coral reef. The quote-unquote boring zone is actually the scientific goldmine of the whole operation.
So, here is your next test. The hard, cold data is screaming at you to switch your plan and go study the seagrass. Do you do it? Well, it turns out students who just blew 4 hours and a bunch of lab tests staring at the beautiful Sunrise Reef, they desperately resist abandoning it. They will argue until they're blue in the face that they should stay, completely ignoring the absolute fact that their initial strategy is totally failing.
Then, suddenly, Day 3 hits, and the whole vibe of the simulation gets real dark, real fast. A tropical storm warning drops. A massive, high-stakes go or no-go decision lands right on their desks about sending down the deep reef submersible. And just to really dial up the anxiety, the teacher puts a timer on the board. Exactly 5 minutes. The pressure just skyrockets.
And this isn't some trivial choice either. Launching the Deep Reef expedition costs 6 dive hours, 3 lab tests, and $200. To put that into perspective, that's more than half of their daily resource allowance just to attempt the dive. If they go and it's dangerous, they lose everything. If they go and it's safe, they discover this groundbreaking deep-sea fan coral. So the really terrifying question is it actually safe to dive in a storm?
Let's just look at the actual numbers for a second. The safe limits are laid out clear as day. Temps need to be below 15 degrees, currents under 2.5 knots, and visibility above 5 meters. Now the Day 3 storm data? 13 degrees, 2.0 knots, 9 meters of visibility. The math definitively proves the dive is 100% safe. But here's the kicker. Just hearing the word storm makes half the classroom blindly panic. They freeze up, they start guessing, they argue, instead of just reading the environmental sheet sitting right in front of them.
By the time the storm clears on Day 4, the consequences of that panic, or for some, their careful data reading, finally catch up with them. Sunrise Reef, that gorgeous zone everyone was so obsessed with, it's completely closed down by high waves. But seagrass flats, the boring mudlawn, because it's protected by the cove, it remains wide open and just keeps pumping out the best data of the week.
Finally, the dust settles. Day 5 arrives. The research reports are handed in, and the kids start tallying up their scores. But this is the exact moment the teacher pulls back the curtain on the grand design of the entire week. It's time for the big reveal.
And this brilliantly illustrates the stark reality of the math. The boring strategy, meaning the teams that consistently studied the seagrass and actually trusted the safe data for the debrief, they were racked up 15 to 22 points, putting them right in the top tier. The flashy strategy, the teams that stubbornly stuck with Sunrise Reef and totally panicked during the storm, they scored an absolutely abysmal 1 to 6 points. The empirical proof is literally undeniable. Boring, reliable data structurally crushed flashy intuition. Every time.
But the teacher doesn't just hand out grades and stop there. They hit the students with a really pointed question. Why did you stick with a bad plan on day 2? The data flat out told you the pretty reef was a dud, yet so many teams refused to pack up and leave. And right here is where the true psychological heist is finally unveiled to the classroom. The teacher explains that they fell headfirst into what they call the "we already started" trap. In psychology, we formally know this as the sunk cost fallacy. It's that stubborn tendency our brains have to just keep going with a failing strategy simply because we've already dumped time, money, or effort into it, not because it's actually working. The game perfectly, and I mean perfectly, simulated this exact cognitive bias. Then the teacher throws out another tough question. Why did you panic during the day 3 storm instead of just checking the numbers? Why did a straightforward go or no-go decision, where literally all the facts were handed to you, trigger such a visceral, fearful reaction over basic logic? That is when they introduce the scary headline trap. Researchers call this the availability heuristic. It happens when we let a dramatic event, a really scary word like storm, or a piece of shocking news make us completely panic. It totally overrides our ability to just take a breath and calmly check the actual statistics. It's the ultimate showdown of feelings versus facts. Finally, the teacher loops all the way back to the very first choice those kids made. Why did you skip the muddy seagrass flats on day 1? Think about it. The data hadn't even arrived yet. And almost everyone, and hey, maybe even you at the start of this explainer, ignored the absolute most valuable zone based purely on aesthetics. That, my friends, is the familiar path, otherwise known as status quo bias. It's our brain's deep-seated desire to stick with the first, most comfortable, most familiar plan it sees, even when cold, hard, empirical data tells us we desperately need to change direction. And in that moment, the students realize the Cove was never really about marine biology. Not at all. It's an entire simulation about how our own brains lie to us. So, the crucial point is, how do we actually fight back against these mental tricks? Well, that's where the patience framework comes into play. Let's look at the first 5 letters, which basically act as a kid-friendly decoder ring for some pretty complex cognitive stuff. P is bounce-back thinking. A is plan B thinking. T is a brain check. I is telling a real clue from a guess. And E is feelings versus facts. It literally hands them the vocabulary to spot their own flawed thinking in real time. And the crazy thing is, it works beautifully. According to the teacher's guide, the ultimate sign of success during this debrief is when a 4th grader raises their hand and says, "My brain picked Sunrise Reef because it was pretty, but the data wanted seagrass flats." That moment of metacognitive awareness, where a kid can actually separate what their brain intuitively desired from what the objective facts proved, that is the absolute triumph of this kind of experiential learning.
Let's wrap up with a final thought and bring this right back to you. Because these biases don't just mess with 4th graders, right? They drive the stock market, they ruin business strategies, and they heavily impact our daily adult lives. So, the next time your brain demands the flashy, familiar, comfortable option, will you remember the boring seagrass? Are you going to remember to check the data first? Thanks so much for joining me on The Explainer, and remember to keep questioning your own thinking.